Uh, Good morning, students. Am I audible?
Yes, sir.
Yeah, thank you, ma'am. We'll start with your class. Before we start your class, we'll go through your timetable. Okay. The Monday, if someone is uh, taking a class. Any of your faculty inform that they are going to take the first one on Monday. This Monday, on 11th. Yes, ma'am. Is any of the faculty informed you saying that they are going to take the class on Monday? Who is the CR? CR can you can talk. I mean, if it is informed, informed. If it is not informed, I will take the class because I already told you there is a lot of syllabus to be covered. Okay, ma'am. See, if you are interested, then only the results will come. If you are not interested, result how many number of classes your faculty take, well, the result never comes. Remember. See, almost 23 classes I have taken as of now. But 23 is not good enough to uh, complete your MSc one kind of a syllabus. Getting now. So it shows that none of the faculty is informed. So I'm going to take your class on Monday from 9 to 10. Okay. And anyhow, we'll be having a class on Tuesday, 10:30 to 11:30 and 4:30, 2:30 to. I don't think somebody is informed you on Tuesday also. Sorry, Tuesday. So I'll continue on Tuesday so that we'll reach to some kind of a syllabus which is a reasonable base. Okay, otherwise, it becomes a very difficult. Okay, so please bear with me. See, you guys has to see the number of extra classes we have taken. One, two, three, four, five, six, seven. If you remove 7 out of 23, what happens? You will get only 16 classes. Okay, but we pre-planned, but still due to some kind of uh, holidays and all those stuff, right? So we could not reach to our target. We are left with only 1 week, one more week. So in this week, from 18th onwards, I think you have exams, and this week you have holidays also. I don't know when is holidays, how many holidays and all. Really, I'm not sure. So that's how Yeah, I'm audible.
Yes, sir.
Yeah, there is a power cut again. Today is a second Saturday, right? So I don't expect the power to turn up again. So we need to. I'm now I connected with the mobile data, so there will be some issues. Please don't complain saying that, sir, your voice is not this that. Okay. So anyhow, I'm trying my level best to speak properly, but due to network issues, I'm that's not in my control. Okay, right? So what I'm telling you guys, I'm going to take your class on Monday from 9 to 10. We'll be having a Tuesday class scheduled one. Tuesday afternoon also I'll take two classes. So let us see how that goes. And Wednesday I'm not sure whether those are holidays or not. Okay.
Sir,
Yes, ma'am.
so chemistry sir said that sir will take class on Monday in the first hour.
Okay then. No issue. That's what I was asking and nobody is talking. Okay. So there is no holiday list was there, so I can't help it. Okay. So anyhow, we have class here, so don't allow anyone to take this afternoon classes. If somebody is told, inform you guys that they are taking Wednesday as well. If any faculty inform you saying that they are going to take Wednesday classes afternoon, it's not scheduled for you. Yes, ma'am.
No,
Okay,
sir, we
okay.
don't have any class.
Yes, ma'am. So nobody is informed as of now. So I am informing you. Okay, I'm going to take this class, two classes. Wednesday, I don't know whether college is there or not, holidays, all this stuff. But if if college is there, I'm going to take it. Okay. And Saturday we have any classes there, that's fine. Okay. After afternoon, I don't know. Today also, including. So many people I heard CSC students are asking me, you guys are not turning up to take class. I already informed you guys and I posted my schedule to you. That shows the kind of the interest that you guys are. Yes, sir. Please keep interest in your studies. Okay, not your faculty has to take initiative to take extra class. You have to talk to yourself. So you need to decide which subject is interest to you, which gives you a placement, which gives you a life. Right. So those are the subjects that you have to concentrate. Don't think about the other 5 to 10 people who are very junk in a class. Okay? If you think that way, right? It will screw your life best. Okay. Okay, we'll start with your class. So the next program we'll talk about a Fibonacci series up to n terms. Okay, so what we discussed yesterday, we discussed about loops,
While
right?
and Phillips.
Yeah, loops. As a part of loops, we categorized your loops into two types. One is entry
Entry, exit.
Control.
control.
Exit
Second one is exit control. Entry control, we have two. What it is, while and for loop. So we discussed what are the general syntax of this. In this, we have done some kind of a programs. Okay, the exit control one is do while. Similar kind of a construct. Okay, whatever the way we studied while and for do while also we'll discuss in the same. but mostly many people doesn't use or do while. They use either while or for. You can use this also. Nobody is going to stop you. So if a given a question, right, if they're not mentioned, saying you have to use while loop or for loop to solve this problem, you can use any kind of loops, any kind of iterational statement. If they mention specifically, you have to use only that. Okay. So let us say an example. You go here, see here, LCM using while and if, GCD using for and if. So if they mention for in computing your GCD, don't use while here. Okay, that's a blunder. Okay, and LCM using while means you have to use only while. Okay, so that's how it is. So whatever it is given the question, based on the question, you have to write your program. And that's why I'm saying don't mug up your programs. You have to build your logic. So based on the logic, you have to write your executable statements to meet your requirements of your program. Okay. So we'll start with your program anyhow. What it is, Fibonacci series. So if is anybody knows what is the Fibonacci series? Fibonacci series starts from 1 and 1 will be there. So these are the seed points basically. Okay, Fibonacci 1 is 1, Fibonacci 2 is 1. Okay, you have to generate the next Fibonacci series based on these values. Next Fibonacci is f1 plus f2. Okay, so f1 plus f2 you get as 2. Okay, now what these things, okay, moves on. So 1 plus 2. The next one you have to add up these two. Next one you have to add up these two. Next one you have to add up these two to get all this stuff. This is called Fibonacci series. Okay. So now what to do? Your see, this was f1. This is f2. You generated your f. Now you have to generate your f here. This fellow. So the f1 becomes f2. F2 becomes f. Yes or no? Then you can generate. So before modifying all this stuff, what you have to do, you have to make your f1 as f2. Okay. Then your f2 is your f. Okay. Then f has to be generated using. So initially you started with this and this. You got your f as this. I got up to this. Now what? I said f1 is equal to f2. So what do you mean by that? F1 becomes what? F1 becomes what? F1 is
F2,
F2 is what?
1, 2.
1. This is 1, right? F2 is 1. Next is F2 is F. What is F in this case? F2 is F. What is F?
2.
2.
2.
2. That's fine. So now you generate, how you generate once you have F1 and F2. F is equal to F1 plus F2, right? F is equal to F1 plus F2. So 1 plus 2, which is 3. So you got your 3. Okay? F, you got it. So again what? Again you have to shift all this stuff. Okay? So F1 becomes F2, F2 becomes F. You have to generate your F as F1 plus F. So what is your previous F2? Your previous F2 means
2.
previous step. 2. So F1 is 2. Okay, getting mark. So now F2 is F. What is in your previous step? What is the value of your F? 3. So substitute here 3. Now your F1 is pointing here, F2 is pointing here. You have to generate this. So how to generate is add up those two. So 2 plus 3, which becomes 5. So you got your 5 here. So like this, you have to generate till what point? They will ask n number of terms you have to generate. N number of Fibonacci numbers or Fibonacci series. Okay. So n terms you have to generate. Okay. N terms means you have to count. Let us say n will be 7. Let us say 7 means you have 1, 2, 3, 4, 5, 6, 13. Next is seventh one. So once you generate seventh one, you have to stop it. Okay, getting ma. So this is how the logic for your Fibonacci set. So you tell me what are the inputs that you require for this program.
F1, F2.
Yes, very good. One F2 seed points is compulsory. These are the inputs, right? Next is the number of terms that you have to generate. N. Getting ma. N also is input. Your output is your series. Okay. Your series one starts with 1, 1, right? Then 2, 3, 5, 8, like this up to n terms. Because this n terms is so what is the logic that we studied there? We studied you have to generate f using f1 plus f2. Okay. Then you have to move upon f1 will become f2, f2 become f. So this will keep as a part of your loop. This has to be generated continuously because it generates like this. Right? So, but these terms are already is given. You have to print those things ahead of your loop. Okay, two terms are completed. So after that, you have to do n is n minus 2. Why n is n minus 2? Because 1, f1, f2 is given to you, right? So then you have to take some kind of a I is equal to 1. Okay, you have to write while. Okay, I less than or equal to n. Okay, do. What do you want to do? Keep this syntax here. So where is your Fibonacci number in this logic? Which variable holds Fibonacci number? Newly generated Fibonacci number. In this, which variable is holding your Fibonacci number?
F.
Yes, very good. Who is this? Who is this? What's your number?
5, 9.
5, 9. Very good. Too good. I mean, that's how you have to observe. Not only attending classes is important, your attention also is. Attending classes, getting attendance, getting marks, all those things. Anybody can do it. When you switch on, right? Connect to your class, keep your mobile there, do your work. Okay. That way you will come out of your attendance. But who will listen to your class? Understand what your sir is teaching. That's important. Okay. So after this, you have to print. Okay. Print what? Your F basically. See, this has to be printed. This is I know F1. This I know F2. F is next Fibonacci number. This has to be printed. Until unless you print this, you don't get anything. So you assume that your Fibonacci numbers are integers, right? Yes. Right, you have to print your F. And you increment your I plus and all. That's it. I mean, apart from this, nothing is there. Is there any problem in this rewriting the code for anyone? You guys has to tell me how to write the code now. Okay, then I'll start writing. Okay, that's how it works. Otherwise, it is kind of a watching a movie. Okay, you don't get anything if you do that. Start with. So, what are the inputs for you? Inputs are F1, F2, N. Right? In F1, F2, N. Now there is a variable that I used here, I. So this has to be declared, right? I. Now what? I know Fibonacci numbers I am trying to generate from 1 onward. So F1 will be 1 or both in. F1, F2 is 1. Seed point is the next what? You have to printf enter n value which indicates the number of Fibonacci terms. scanf percent D ampersand N, right? Now I have to print F1, F2. What is that? Percent D space, right? F1, F2. Printed, N can be entered anything. So, but I'm assuming that you enter your proper N value. Okay. So, if N is 2, you have to print only these two values. Okay. If N is greater than or equal to, only this has to be get printed. Okay. Then N is N minus 2 you have to do. Why you have to do N is N minus 2? Can somebody tell me this?
F1 and F2 are given.
Yeah, F1, F2 already printed two numbers, two Fibonacci numbers already printed. This N is talking about the number of Fibonacci terms. So 2 printed, 2 has to be deleted from N. I deleted it. Then you start with your I is equal to 1. Okay. Or you can use a while loop also, for loop also, whatever you want. For I is equal to 1. Okay. I less than or equal to N, I plus. So in this, what to write? The logic I said, right? So this logic you have to write. Okay. So to generate your Fibonacci, because F1 is F2 is given to you. So how to generate your F is F1 plus F2, right? Print your F percent D space, right? Your F, right? Now F1 is F2, F2 is F. Okay. After this, I think you don't have to do anything because I is taken care by. Okay. Getting. So it's initially I started with 1. Let us assume that your N is 1. Assume that you entered 1. 1 greater than 2. Greater than or equal to false. So it never prints it. N is N minus means 1 minus 2, which is a minus 1. So I is 1. 1 less than or equal to minus 1 false. So it won't print anything in this. Assume that your N is 3. Okay. 3 greater than or equal to 2. So it prints all this. N is N minus means 3 minus 2, which is 1 in this case. Okay. So you start initializing this. I is equal to 1. So after initializing, it jumps to your conditional statement. So 1 less than or equal to 1. N is updated. 3 minus 2, right? 3 minus 2 is 1. So 1 less than or equal to 1 true. So whenever it is your conditional statement is true, all the statement blocks which is a part of your for loop is get executed. Okay, so F is 1 plus 1, 2. So the 2 I am printing. Okay, then F1 becomes 1, F2 becomes 2, I plus plus, I becomes 2. 2 less than or equal to 1 false, so it comes. This is how it works. Okay. Okay. Fine, right? You have to test for all your possible combinations whether really your program is working on. Enter the value n 1, so it is not printing. Good, run. So enter value 5. So 5 Fibonacci numbers. 20 Fibonacci. Okay. That's how it looks like. So now, so they may change the question saying that you generate your Fibonacci numbers up to some kind of let us say below 2000. So you have to generate all Fibonacci numbers below 2000. So how to change your logic for this? Can someone tell me this? You have to change this. This logic is based on the number of terms. But what I am trying to tell you, if given a question, you generate a Fibonacci numbers, okay, which are below 2000 number. There is a one thing that you have to do. What is?
F less than 2000.
Yes, that's it. So this, so where to keep that, ma? In this place. That's too. Okay. So that's how you have to see that 2000, whatever I have given, I'll give as a part of some n again. So if it is n, so f less than or equal to n, you have to do it. Apart from this, you don't have to do it. So there is no need of your I and all. There is no role of I here, right? So I removed it. Okay. Now we'll see really how this works. Okay. So enter n value. Okay. Below which you want to generate web series. Right? Good. So let us enter some kind of a number. I want to enter 10. But what happened here? It printed 13 also. So you have to take care of that. Okay. So where it is printing here. So you have to have some kind of a condition. If okay, f is less than or equal to n, do print this. Otherwise, don't print. That's how. See, this simple as that. So run. Just see 50. So 50. These are the. So everything is proper, right? 8, 13, 21, 30. That's it. Okay. And you have to check. Many students, what they do, when they run, when they give some kind of a number, if output is come, then they close that. But whether your output is proper or not, you have to check it. Okay, that's how you guys has to do. Right. I'll remove this. The next program I'll go ahead. GCD for using for loop. Okay. Here he is not asked or informed any kind of which loops to use and all. So here we discussed with the while loop, okay, and we are written using for loop. That's good. So GCD using for loop and if state. Let us see that. What is the GCD?
Greatest common
Greatest common divisor. So what are the inputs that you require for this? GCD for two numbers. Okay. So n1, n2 is given. So output is GCD of n1 comma. So assume that you have given 4 6. So how you generally do this? Evaluate this GCD. You take a 4 6. So you try to divide this. 4 ones are 4, right? So 2 you get it 4, right? 2 twos are 4, so 0, right? So generally, what you do is you have to take the small number on the left hand side, bigger number in between. So out of these two, you have to find which is a bigger one, the maximum one or the minimum one. Okay, minimum one will be the first one, the other one is the second. So that way, now what you have to do, you have to check. Okay, so how to do the get your remainder? Remainders are important because the GCD is 2 here. Okay, so which is the remainder of your original n1 and n2? 18. Now what happened here? This was n1, this is n2. This was your remainder. But again, what you're doing, this remainder you are done with 4. So what it was, see, in this place you have n1, in this place you have n2. So this has to become n1 and this has to become n2. So your n1 is here, again n2 is here. So how to update? You have to get your remainder as n2 mod n1, right? Yes or no? So n2 is 6. 6 mod 4. What it is? You get r as 2. Now what? My remainder is not 0. So till this remainder is 0, right? I have to repeat. So what you have to do now? N1 is r now. So n1 is r. Okay. Now n2 is what? N2 is n1 actually. But before this, what do you have to do? N2 is n1. You have to do it because if you update your n1, you lose the value present in n. So n2 is n1, n1 is r. Okay. So n2 becomes n1. What is the previous n1 value? 4. Okay. Then n1 is remainder. What is your n1? 2. So again you have to repeat this. Okay. Till what point? Till your r is 0. So whenever the r is, whenever r is c, again you have to repeat this. Okay. Repeat this logic. Okay. Now r is n2 mod n1. What is n2 in this case now? After this loop, 4 mod 2, which is 0. Okay. Then if it is 0, you can come out of your loop. But still, what you can do is n2 is n1. N2, if you do this, okay, n2 is n1. N1 becomes what? N1 is previously 2. Okay. N1 is r. R is 0. Okay. Then you talk about while loop. While r not equal 0, but r in this case is 0, you come out. So in this instance, where is your value? Resultant is inside your n2. But if you come, if in this condition, if r is equal to 0, okay, you can break and come out. So this is a kind of a jump state. That's what he is asking. Use what? Use for loop and if statement, right? So we'll use these kind of if statement inside it and come out before you update this. So before you update this means your remainder, your answer is inside n1. Okay, I'll explain this again. Okay, don't worry. Inputs are n1, n2. Output is of n1 comma n2. So in this, if I enter n1 as some kind of a 3, n2 as a 2, right? So how you do it? You always take your smaller number and a bigger number in. So that's why you have to check which is a bigger out of this or smaller. Okay. So the smaller will be n1 and bigger will be n2 in our code. That will decide how to do it. How to do it is you just compare it. If n1 is greater than n2, then only you have to swap the numbers. How to swap? You take some kind of a temporary, without temporary variable also, we have done it, right? N1 is n1 plus n2, like this, we have done it. Our easy way of doing it is take some temporary variable. T is equal to n1, n1 is equal to n2 is equal to 6. This is how you keep your n1 is always the smaller. Okay. So after this, what you have to do? You have to take your remainder. Remainder is okay. Otherwise, we'll take while loop. What is the question is asked? Use for loop, right?
For loop, sir.
So infinite for loop will do it. So I forgot to mention you. Infinite for loop can be written as this. If nothing is there inside this thing, right? Or if something also is there, expression 1 semicolon expression 2 also is there. Nothing present in between the two semicolons is indicating infinite. Okay. So please remember. So I'm going to use this. That's why I just explained. So what to do? For I have to find my remainder first. Remainder is with whom to whom? bigger one to smaller one. So n2 mod n1. So here, if remainder is equal to 0, okay, you have to do what? Break. Break is a kind of a jump statement which takes you out of your one for loop. So you have only one for loop. This is not a nested one, right? So it will do what? It takes you out of. So if you have a close for loop, close of your close brace of your for loop, the break, okay, takes you the next statement of it. Okay. So once you, this indicating what? This condition, okay, in my previous explanation. So assume that you are in this case, n1 become 2, n2 become 3. Okay. So R, I'm computing this. Okay. R is n2 mod n1 to 1. Is 1 is equal 0? Yeah, no. So break won't work. Now what you have to do? You take this 2, 3, 2 ones are 2, so you get your 1 here. So this was your n1, this was your n2. This is a remainder. Now your n1 has to become a remainder. So before you updating your remainder, okay, n2 you update to 1. So if you do directly n1 is equal to r, okay, what happens here? N1 will be r is what? 1. So where is your n2? N2 has to become 2, right? So you lost your value in this because you already updated your n1. You don't get the 2 value whatever your n1 is having. So that's why what you have to do? You have to start assigning with n2. Start assigning with your, so n2 has to be what? N2 has to be n1. So in this,
N1.
N1.
and n1 has to be r in this. Okay. So now n1 is r means here it is n2 is n1. N1 means 2. So it is, so 1 2 is a 2. So 2 means 0 you get. Okay. So what to write here logic? N2 is 1. N1 is k. Right. Then we'll take again. I mean, take an example to make you understand this. This logic anyhow we will write it. A simple one. First of all, you guys have to understand how to come up with these conditions is important. If you try to remember these things, okay, you never write any kind of a code. It's very difficult to write. You don't remember those. You have to generate those conditions with the logic. Okay. So you take n1 is equal to some, give me some kind of numbers. You take it, n2 is equal to 3. Good. Or 12. Take, right? Now all are fine now here, right? But always make sure that n1 is lesser. So once you have this for loop, for r is equal to, what is r now? R is n2 mod n1. N2 is what? 12 mod n1 4. What do you get? 4. Right? Is the 4 is equal to 0? No. So what you are doing here? So I am trying to do this 8, 12. Okay, 8 ones are 8. You are getting 4. Now I got this. Now in your common mathematics terms, what you going to do now? Here. In this computation, what you are going to do now?
N2 equals to N1.
Yes, ma. See, 8 you keep here, right? You keep your 8 here, trying to compute again. 4 2s are 8, you 0. So, we see previously n1 is this n2, but n2 actually, so replicate this here. So, n1 has to be 4, n2 has to be 8. How to make this? That's a question. Okay. So, this was a remainder in our program. Okay. So, n1 has to be remainder. But if I do this, N1 is getting updated with the 4, but previous value which has to become N2 will lose if you do assignment of this ahead of your N2 is equal to, right? That's why you have to first do N2 is equal to, then you do. Okay. So that's what I have written. How to come to these conclusions is this way. Okay. So N2 is N1. Now N2 is N1. What is N1 here? N1 is this 8. Now N1 is what? Now remainder, right here. Remainder is how much it is now? 4.
4.
Right? Yeah. So this is the last statement to be executed. It goes here. This is infinite loop. It is always true. So you have to compute what? R is equal to N2 mod. N2 mod N1. What it is? 8 mod 4.
0.
0.
0. Okay, so I got my remainder as 0. 0 is equal to 0. True. Break. When I break, what is my resultant I'm expecting here? Actually, the 4. Where is your 4? Here. Okay, so it is the variable. And so when you come out, you print saying that GCD of %d comma %d, okay, is dash in double quotes comma. This %d is for N1, N2, and N1, N2. Already these has got updated, right? You take some kind of a N1 underscore T, N2 underscore T to hold the original values. So you can keep your N1 underscore T, N2 underscore T. Actually, your GCD is present inside your. This is how you have to build your logic for any kind of a problem. Okay, so that's how your programming looks like. I hope you guys understood. Is there any doubts in this, ma?
No, sir.
Thank you. So we'll write the code for this, right? See, I'm showing you how to build a logic. After building a logic, how to write your program. That's okay. So here, when you look at these many variables that you require, remainder also. So n1 into int n1 into, right? n1 underscore t, n2 underscore t, and you have r. So printf enter two integers to find GCD. Right? Scanf %d %d. Export ampersand n1 ampersand n2. Okay. Now what? You have to decide which is a bigger one. If n1 is lesser than n2 is fine. You have to check it. If n1 is greater than n2, what is greater than n2? You use r also or n1 underscore t as a temporary variable. That's fine. Okay. n1 underscore t is equal to n1. n1 is equal to n2. n2 is equal to n1 underscore t. I just used it, that variable. Okay. Right. Now what? n1 underscore t is n1. n2 underscore t is. Now you have to start using your loops. Okay, for infinite loop, this one, right? So what I have written here, remainder I computed. Okay. R is equal to n mod n1. Why I am doing n2 mod n1? Because I am making sure that my n1 is always less because of these states. So that's why I am doing this. Okay. Now, if R is equal to 0, you have to do what? Break. Okay. When you break, it comes out. Okay. So what do you mean by that? So 4 2 is that. Let's say n1 is equal to 4, n2 is equal to 2 is. So after that loop, okay, if statement, n1 becomes 2, n2 becomes 4. Right? So it is infinite loop. R is equal to n2, 4 mod 2. So you get as a 0 your output. 0 is equal to 0, true, break comes out, and you're trying to print your GCD, right? So where is your value GCD greatest common divisor, which is N1? What is N1 value? 2. Is this proper? GCD of 4 and 2 is 2 only, right? Yes or no? Getting mark. You have to check for all conditions. You have to check for all conditions. Next, what you are doing inside N2 is N1. N2 is N1. N1 is, if you print your printf GCD of N2 comma, sorry, %D comma %D dash. So what is this first percentage? N2 or N2 underscore T N. Four six. GCD is 2. That's fine, right? So please try to check for all conditions whether really it is working or not. 4, 12. So enter 1 and 1. So anyhow, it's working fine. Check it for all favorable conditions. Okay, right. Is there any doubt in this program? See, whatever he asked, okay, we have done it. You have to use a for loop and if statement. Okay. I have used a for loop and if statement. So what is this for loop? For loop is, this is infinite for loop. So if I keep 1, what happens? Please tell me what happens. Compile. 3. Nothing happens. What is this the expression between your two semicolons is what? Yes, ma'am. The expression between two semicolons is your for loop
Conditional.
conditional state. Okay, so this is a relational kind of statement. So this is always, 1 means always true. So this is always true. Okay, so if it is always true, there is a what it is?
Infinite.
Infinite loop.
Infinite loop.
That's it. Okay. So even though you keep your 1 or not, it is infinite loop only, which is as equivalent as while 1. Okay. While 1, open brace, close. So all your statements are here in between. Okay. So I hope you guys understood how to use your for loops, while loops. This is a simple loops we are using. There is a nested loops. You can use a while inside for, okay, or for inside while, okay, or while inside while, for inside for. So all those combinations also you can use. Okay. This is called nested for loop or nested loops basically. Okay. Right. The LCM of LCM using while and if. I'm not sure whether I can use all the stuff which was there. What is an LCM? How to do it? So input is what? 2 numbers.
N1 and
Again, N1. Output is what? LCM of N1 comma N2 is my output. Okay. So you can see, mathematically speaking, I can compute my GCD. Okay, GCD multiplied by the LCM is your product of 2 numbers. Okay, N1 star N2. Yes or no? So if you know this logic, once I found my GCD and I know numbers, so your LCM becomes N1 star into divided by GC. No, getting ma. So I can directly write that code actually. So of this and this is what to do. I know this is a GCD. Okay. So N1 star N2 divided by GCD. So this N1 underscore T star N2 underscore T. Okay. Divided by. This is what else mathematically is done. So what is the LCM of this fellow? You take 4 and 6. 2 twos are 2 threes are. So what it is 12, right? LCM is what? 12 for this. What is the GCD for this? 2. What is the formula I told? LCM is N1 star into. So 4 star 6 divided by GCD, which is 2. Okay. So what it is? 12, I got it, right? LCM is 12. No. So mathematically speaking, it is correct. Okay. So I can do that way also. Not an issue. Four, 6 I have given, right? So we'll give the same. But really speaking, it's not the way to learn your loops. So as a programmer, you have to do it manually. Really understand how best that you can do it. But you have to remember this. Okay, how to compute your LCM. You can compute your LCM using GCD logic as well. The kind of the question is given, find out the LCM using a GCD, you can do this code. Okay. So generally, if I given 4, 6, okay. So what you are doing is you are taking some kind of a 2 here, 2 twos are, 2 threes are. So now nothing will go ahead with. So that's why you do what? 2 star, 2 star, 3, 12 you get it. See, this 12 is get divisible by this and this. So 12 mod 4 or N1 is equal to 0. Okay. Your result mod, okay, your N2, which is in this case say equals 0. So you have to see this 12 is greater than your N1 and N2. So what I'm trying to do is I'm taking biggest of these two numbers, okay, N2. From here, okay, I'm trying to increment one value at a time. Okay. So N2, so the result LCM, I'll get now biggest of these two is what? Okay. So this LCM, what I'll do if the resultant is mod N1 is equal to 0 and LCM mod N2 is equal to 0, that is what my both has to be true. Okay, this and this. So the resultant has to be divisible by N1. The resultant has to be divisible by N2. Then only the whatever the resultant I get is my value base. If it is not divisible by this is not divisible by this and this, I have to increase LCM is LCM plus. So in this case 6 mod N1. What it is 4. Okay. I get some kind of a 2 is equal to 0. No, false. So what you have to do? You have to increment LCM plus 7. You get it 7. 7 mod 4. No way. I mean, this is also false. So again, increment 8 I'll get. Okay. 8 mod 4 is 0, but 8 mod N2 6 is not a 0. Then again, you have to increase your LCM plus 2. I'll get a 9. Okay. 9 mod 4 here itself it fails. It becomes a 10. 10 mod 4 again it won't do it. 11. 11 mod 4 it won't do it. 12. 12 mod 4 true. Okay. 0. Then here 12 mod 6 is 0. So this is what my. So every time what you have to do, you have to check for okay, whether it is getting divisible by your N1 as well as N2. Okay. So if it is divisible by both the things, then you can keep, okay, that as your result. Just increment your result. How to get this? You have to get the maximum of these n into assigned to your LCM, trying to keep increment. Okay, so the logic behind it. Why and if. Right. So what are the things? Inputs n1 n2. Printf enter two numbers to find LCM. Right? Scanf %d %d n1 percent n2. Right? So after this, what do you have to do? You have to find biggest of these two and assign to LCM. So declare some kind of a variable. LCM is equal to n1 greater than n2 n1. Otherwise, right? So I'll keep while one. Okay. Otherwise, we'll take some kind of a flag. So what I want to do is this has to be in an infinite loop. Okay. If LCM mod n1 equals 0, okay, then if LCM mod n2 is equals 0, and do what? Okay. Here, other part, what I'll do, LCM plus. Okay. So you will try to trace this program. Okay. What are the loop I've done in? Right. So take some kind of a numbers. N1 is 4, N2 is 6, right? LCM is, I'm tracing one by line 10, I'm doing it now. Okay, line 10. N1 is 4 greater than N2 6 is the question. Is this true? 4 greater than 6, false. False means what is the result of your ternary operator at line number 10? Yes, ma'am. It is N2. Okay, so N2 is what? 6. So my LCM is 6. So at line number 12, while 1, so it is true. Okay. Then what I'm trying to do, line number 14, if LCM, what is LCM? 6 mod N1, what is N1? 4 is equal to 0, I am checking. Okay, is equal to 0, this is equal to 0 or not? What it is? 2. 2 is equal to 0, false. False means I'm doing LCM plus plus. Okay, so LCM plus plus means LCM previously 6, so it becomes 7. Again, it goes back to while loop 12. So 12 is a true always. Again, what it is doing? LCM mod n1. So 7. Yeah, I'll write it here. 7 mod 4, which is a 1. 1 is equal to 0, false. So this becomes 8. Again, it goes to while 1. Okay. Again, it is 8. 8 mod 4, true. 8 mod 4 is 0. Okay. 0 is equal to 0, true. It goes inside, true. So again, you have if LCM mod 2 is equal to, sorry, what is N2 now? 6, right? Is equal to 0. What is the LCM here? 8. 8 mod 6, which is, what is the resultant of this?
2.
2. Is 2 is equal to 0? No, false.
False.
False means it is getting incremented. So 9. So it goes, your execution statement goes to line number 19. So it is getting incremented 9. Again, the while loop, okay, line number 12, okay, it is true. Now your LCM is 9. 9 mod 4. What is the result of 9 mod 4?
1.
1. This is 1. 1 is equal to 0. False. False means it never enters into if loop. So again, LCM plus plus will happen 10, right? Okay. Again, after this, it will go to where? It will go to while loop again, line number 12, to check whether your expression is true or false. So it is always true. So if condition again, if LCM is what I'm left with 10 at line number 14. I'm writing. Okay. LCM 10 mod N14 is this. What is the resultant of this? 10 mod 4. 2. 2 is equal 0.
2.
2 is equal 0 is false. So again, it never enters into if loop. So LCM plus plus 11. So again, it is an infinite while loop. So it comes here. Your if loop, if statement, line number 14 again comes here. 11 mod 4. Is 11 mod 4 is true? 11 mod 4 is equal 0 is true. What is the
No.
resultant
No.
of this? 3. 3 is equal to 0 is a false. Again, it is getting incremented 12. So again, it comes to your if. Okay, this becomes a 12. 12 mod 4. 12 mod 4 is what? 0. 0 is equal to 0, true. Again, it goes inside now. Line number 16. So your LCM is what? 12. 12 mod 6. 12 mod 6 is 0. 0 is equal to 0, true. Break. Whenever it breaks, okay, it comes out of your loop. Okay. Whenever it comes out of a loop, where is your result now? Where is your result? Into this code, where is your result of 4 and 6, in which variable it is?
LCM plus plus.
LCM. This is not a plus plus, is an operator. LCM is a variable. So it is, see, this is a variable. So finally, your value is present inside, your result is present inside your LCM. So now the first percentage is for N1, second is for N2, third is for LCM. Compile it. Run it. See, I'm not saying there won't be any kind of a problems in the code, whatever I've written. I'm testing for only very few conditions. So you have to make sure that every condition is met. Okay, 4, 6. 4, 6, you got 4. Okay. This is how you guys has to write your program. Okay. I'm done with your today's class. Okay. What we'll do is we'll discuss. Okay. Make note of all these things. Practice again all this and come up with some kind of a doubts in a Monday's class. Okay. I'll stop recording it.